Hi class, the topic that we will be discussing today is magnetic resonance imaging, otherwise known as MRI.
MRI was discovered by Edward Purcell and Felix Bloch in 1947.
Okay, so here is a illustration of the MRI. As you can see right here is a human that is encapsulated within the MRI in the shield. Usually it looks like a white donut. This is just like a primary illustration of it. Here you have the four main components: the primary magnetic field, as well as the gradient coils, radio frequency coils, and as well as the computer system. Clearly the radio frequency coils are connected to the radio frequency detector. The gradient coils are connected to the computer system, and together they form a circuit system that will come to a revolution in the image. How exactly do MRIs relate to physics? Well, first off, MRI stands for magnetic resonance imaging. During an MRI, a magnetic field and pulses of radio wave energy are used to make illustrations of organs and structures inside the body.
So the human body is made up of 70% water. In a water molecule, there's one atom of oxygen and two atoms of hydrogen. The nucleus of the hydrogen atom is just a proton, which is depicted right here. Go.
When the MRI is turned on, the hydrogen atoms in our body align parallel or anti-parallel once they are introduced to the primary magnetic field, that is B sub 0.
With a radio frequency pulse, we can make the magnetization of the hydrogen nuclei turn 90 degrees away from the magnetic field that was introduced in the previous segment of our video. The magnetic field will cause these atoms to precess, and the machine will pick up this signal.
An additional magnetic field is going to be introduced in different directions with varying strengths. You have the Z gradient that is going to face in the longitudinal direction, capturing axial images. You have the X gradient that is going to be facing vertical direction, capturing coronal images. And you also have the Y gradient that is going to be facing horizontal, capturing sagittal images.
When different magnetic fields are applied to our bodies in different directions with varying degrees of strength in these directions, our bodies react differently, and the combinations of magnetic fields that are applied can be decoded by using the Fourier transform. It is an equation that decodes this information and basically transforms the coded information into an image that we can review and interpret. Here we go.
So, in conclusion, in an MRI system, you have the main magnet, which polarizes the sample. You have the coils that correct the inhomogeneities of the magnetic field. And you have the gradient system, which is used to localize the MR signal. And you also have the radio frequency system, which excites the sample and detects the resulting signal.